Okay, the second method, it is again to prepare the soluble salts. The starting materials involve the acid, the soluble base alkali, or the soluble metal carbonate. It is on page from 17 to 19. Okay. For example, figure 18.9. It is to prepare the salt sodium chloride crystal, which is soluble in water, and the acid is dilute hydrochloric acid, and the sodium ion come from the sodium hydroxide solution, and the sodium hydroxide is water soluble. It is a base which is soluble in water and alkaline. So you cannot use the sodium hydroxide solid to make a salt, because the sodium hydroxide always soluble in water. You cannot prepare a salt solution. The excess sodium hydroxide is mixed with the salt solution. They are a mixture of two substances, because the excess sodium hydroxide cannot be remain in settle down in the bottom, remain undissolved. It is dissolved. So start with, from the alkali and acid. We have a conical flask containing known volume of sodium hydroxide solution, and on the top we add dilute hydrochloric acid into the conical flask from a apparatus called burette. You can control the tap and run the HCl into the conical flask containing sodium hydroxide solution. And when the acid react with alkali from salt and water, the acid is colorless. The sodium hydroxide solution is also colorless and form a colorless salt solution. And we don't know when to stop the reaction. How to know? We employ an indicator. Methyl orange example. The methyl orange displays different color in acidic solution. It is red color. In very alkaline solution, it shows yellow color, and in between the yellow and red color, it is orange. So when you add the methyl orange indicator to an alkaline solution, it is yellow, and you run the HCl into the alkaline solution, and you continue to add the acid such that all the alkali completely reacted. At this point, the solution no longer alkaline, and the solution changed from color yellow to orange. At this point, the color of indicator changed from yellow to orange. Just in this point, at this point, the alkali is reacted. So neutralization is complete. And we know we need to read the reading on the bivouac and know the volume of the acid used for neutralize the known volume of sodium hydroxide solution. For example, you have 25 cm³ sodium hydroxide solution and use 23 cm³ of HCl for complete neutralization. Then you repeat the experiment without indicator, adding the same volume of HCl into same volume of the previous volume of sodium hydroxide solution. After this, the salt solution is concentrated by heating on a steam bath, and you can use a glass rod to check whether it is concentrated enough to see whether a cloudiness is formed. And cool down the hot saturated or hot concentrated sodium chloride solution covered with a filter paper to keep out the dust. Remove the crystal by filtration and do not use large amounts of water to wash the crystal because it is water soluble. And do not use tap water, and do not white water. We need to use distilled water. Don't white water. Use distilled water and need to distilled water and cold little cold distilled water to wash the sodium chloride crystal. And the sodium chloride crystal should be dry by filter paper or hot oven. For the sodium chloride, it is very stable at high temperature. So you use the oven, you have no risk to decompose the salt. That's okay for using the oven. Okay, look at the procedure again. You measure 25 cm³, which that is known volume of sodium hydroxide solution, not in a conical vase, and add the modified orange indicator such that a yellow color is formed, and fill the bivouac with dilute HCl. And run the HCl until the color changes from yellow to orange. The orange color should be persistent, means it is permanent orange. It is not the case that when you add the acid to the sodium hydroxide solution with the indicator methyl orange, as the HCl at the middle is very acidic, and at the center it is orange, around is yellow, but you swirl the fast, the orange color disappear after you swirl the conical fast. That means it is not a permanent color, it is temporary orange. But when you add more HCl, the sodium hydroxide is used up, the orange color take a longer time to disappear. And when sodium hydroxide is reached to less and less, and the orange take longer time to disappear, and as you add one more drop to the conical fast, one more drop of HCl, then the whole solution change to orange, and you swirl the fast, the orange does not disappear. So it is called persistent orange. That means all NaOH is used up. Okay, and you take the reading on the burette and know the volume of the HCl used. And number 4, repeat the whole experiment without methyl orange indicator, with exactly the same volumes of acid and alkali. And then for the stage C, it is to carry out the crystallization and wash with cold little distilled water and dry with a filter paper or oven after the filtration.